And welcome everybody to our Fields and Features segment. First thing we're looking at is the Earth geospace, the Earth's magnetosphere, Earth's magnetic moment from space. You're looking at magnetohydrodynamic pressure here. The scale is nanopascals. So we're going to let this play all the way through for you here. This is the last 4 hours. We've recently seen a slow ramp up in the solar wind density. As a coronal hole wind stream is arriving, at least the initial density wave certainly is showing up as we make the video, and you'll see this accompanying an increase in magnetohydrodynamic pressure. That's the last 4 hours. This also gives you insight into things like Earth's geomagnetism, Earth's geomagnetic poles, where they're located, and so on. It shows you the plasmasphere, the likely plasmasphere and Van Allen belts, and so on. It's the Geospace Magnetosphere movie. Earth's magnetic moment from space. Next, we'll look at Earth's magnetic moment from the ground. We've decided to bring up the polar view today. Again, this is 4 hours of data. This is magnetic flux density. The scale here, nanotesla. So Earth's magnetic moment from the ground level. And when we see periods of geomagnetic unrest and geomagnetic storm, this gives us a great indication of where we're likely to see aurorae, induction into power grids, pipelines, railways, etc. And like the last frames, you're going to see a slight uptick here in geospace delta B, meaning changes to Earth's B field. When you see the word delta in science, folks, that means change in. So changes to Earth's B field. The next thing we'll look at is the heliospheric current sheet. Earth is in a north pole. Oh, first the GOES magnetometers. I stand corrected. So we've seen a divergence here in the GOES magnetometers. These M's stand for midnight local time for the satellite. The N's stand for noon local time for the satellite, to give you insight into where the satellites are located. They're slightly staggered in their near equatorial orbit, and they are geosynchronous satellites at very high altitudes. Anyway, those are the magnetometer measurements by the GOES 16 and 17. There's plasma arriving, and it's part of the heliospheric North Pole-oriented current sheet. You can see that there in green. This top view ecliptic plane field plot is spectacular at telling us the polarity of plasma in the solar system. We'll also show the line of sight view, which shows the solar magnetogram. Here's that. Quite a lot of magnetic organization in the earthly side of the solar disk at the moment, as solar cycle 25 slows its roll on its ramp up to solar maximum a couple years early. So here is the coronal hole line of sight plot. This shows the sun's B field in blue. Keep in mind the data is over an hour and a half old from when we made the video, and the magnetic environment can suddenly change. We've got trans-equatorial coronal holes rotating in here as the north solar polar field migrates and the solar poles flip. Next, a great view here of coronal holes in 193 angstroms from the SDO. Yo, it's the SDO. Interestingly, we're seeing sunspots here at varying latitudes. If you're not familiar with the butterfly diagram, let's get to sunspots next. Great view of coronal holes here. Some well-defined ones, and some more rotating in the east. So we made it up to about 8 sunspot groups there. Now we're down to about 6. We've seen a slight drop-off of solar activity in the past 24 hours. The radio flux has dipped and so forth. Watch our previous video for more on that. And the sunspot to really watch is sunspot 2948. It's still beta-gamma class as far as we can tell. At least it was when we did show prep. So here's another view from the SDO. This is 1700 angstroms, extreme ultraviolet wavelengths. It shows a flattish chromosphere, and it shows dark. It shows darkness where there are sunspots in the 1700 angstroms band. And we'll bring up a close-up here of the southern hemisphere to show you how sunspot 2948 has largely been stable over the past 24 hours. It does have some trailing umbrae there. It's actually shrunk a bit here in the past 24 hours, as you can see in that imagery. We'll let that play through one more time. Then we'll show some additional wavelengths. Let's blast through some more data. Here's 94 angstroms. You can see some activity up here, some flaring. And I would note the way we're seeing sunspots at different latitudes. So around solar minimum, we see more sunspots around here. And during the ramp up, at the beginning of a solar cycle, we see more sunspots at low polar latitudes. High latitudes, I apologize. We see sunspots around the solar equator, around solar minimum, and we see sunspots farther from the equator as the cycle ramps up. So we're seeing sunspots at multiple latitudes continue throughout solar cycle 25. Here's the southern hemisphere in 94 angstroms. If you're familiar with the butterfly diagram is about the migration of sunspots through the solar cycle. So at solar minimum, we see most sunspots around the equatorial region. And then we'll start to see new sunspots closer to the poles as the new solar cycle sunspots ramp up. Here's the X-ray flux over the past 3 days. The GOES 16 and 17, showing us a couple of C-class flares there in the past 24 hours. No major flaring. We do have a small signal here in the proton flux, and that was associated with a massive coronal mass ejection on the far side of the sun. An M-class flare was also associated with that probable proton event. Next, looking at the real-time solar wind, we see the solar wind density has ramped up. So we see a coronal hole wind stream arriving here. Looks like the peak density we just reached at just under 20 protons per cubic centimeter there. So we can expect to see a downtick in the density and an uptick in the solar wind speed, the signature of a coronal hole high-speed stream. Current conditions are only 322 kilometers per second for the solar wind speed, 13.66 protons per cubic centimeter for the solar wind density. KP index is at 1. For your new viewers, that's a measurement of global geomagnetism, geomagnetic calm conditions, and let's do a solar system forecast to get everybody oriented. Here's where things are now. Here's where things will be in a week. We will have a crescent waning in a week. Congratulations on surviving another full moon and not being eaten by a werewolf. Here is the star chart that we bring up daily. The yellow line is the ecliptic. The blue line is the galactic plane. And there's a planetary pile-up continuing here. Mars and Venus right next to each other there. You can see Venus quite a ways off of the ecliptic. You can also see Mercury and Saturn rising ahead of the sun. You won't be able to see Jupiter rising behind the sun, though. It's not quite bright enough. Next, your coronal mass ejection watch. We'll be showing you coronagraphs from stereo A, and at Lagrange point 1, the Soho-Lascaux C3, and the coast is clear for coronal mass ejections. Make hay while the sun is shining. Go out there and be great, folks. Go out there and be great. Anyway, thanks for tuning in. Don't forget to press like and subscribe if you enjoy the content. We'll be back with one more bonus features video. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off from the Smash News Network, least busted name in news.